All right, Marla. I just actually did a video and I didn't actually turn my microphone on, so I'm going to do this again. It's only about 25 minutes, so I apologize in advance. I'm going to try to rush through this real quick, but I wanted to go over some of these things and just get them out of the way, just to see if you have questions on them, and then we can kind of maybe expedite our time tomorrow, and just see if you have questions, then you can kind of answer them, and or I can get them answered for you. Let's start with some of these absolute values. Biggest thing with absolute value is make sure whenever you're solving, we have to take care of anything that's outside the absolute value first, right? So in this case, like looking at number one, again, I'm gonna run through some of these and I'm gonna go through quick. I apologize. Anything that's outside, let's take care of that first, right? So, I would take care of that plus 11. I would keep the absolute value of 3x minus 5 equals, now 3 minus 11 gives me negative 8, okay? Now, typically what I would do is I would split this, right? I would say 3x minus 5 equals the positive, and then I would say 3x minus 5 equals the negative. Okay, and that would solve each one. But in this case, because this is negative, I know that's an impossible problem, right? So in this case, this is no solution. Whoops. Solution. Okay, you cannot have an absolute value equal to a negative number. Traditionally, like I said, we get the absolute value by itself, then we break it up, do one positive, do one negative, and that gives us our two solutions. But in this case, like I said, negative is no good. Let's go ahead and look at number three. Number three can be a little sneaky. Again, you're just going to minus 4 from both sides. You have the absolute value of negative x equals 14. Okay. So in this case, you have a negative in there, but that's actually fine. We're fine with having the negative inside of it. As long as this is positive, we're good to go. So we're going to split this again. So we're going to say negative x has to equal either 14 or negative x has to either equal negative 14, right? Whatever's in here can either equal the positive 14 or negative 14, and that's where we represent them there and there. Again, just change the negative here, so this is going to actually be x equals negative 14, and this one's actually going to be x equals positive 14. So those are my two solutions there. But you should get two solutions each time when we're dealing with the absolute values. Yeah. Inequalities, so greater than, less than, greater than, equal to. Just be careful with this 2x minus 5. Now it's already by itself, which is great. We're still going to split this, right? We're going to say 2x minus 5 is less than 8. And then we're going to say 2x minus 5. And we know when we change that 8 to be negative, we have to flip that sign. So it's going to be greater than negative 8. And then we would just solve it, right? So again, we're going to go plus 5 plus 5. So we go 2x is less than, less than, There we go. 2x is less than 13. Divide by 2, so x equals 6.5, 6.5, or 13 halves, however you want to look at it. This one, again, add 5. 2x is greater than now. Negative 3. So divide by 2, so x is going to be greater than negative 3 halves. Okay. So just make sure when you do the absolute value, when you change that negative, we flip the sign. Same thing when we deal with even if it's just like solving inequalities, right? So let's say I had something to this effect where I said negative, hold on, I got to start drawing better than that. Let's go negative 2x plus 8 equals, 18. Okay. If I'm solving this, actually, let's make it greater than or equal to, greater than or equal to. I would still subtract 8, right? Boom, boom. Negative 2x is greater than or equal to 10. But when we divide by this negative, right? When we divide by that negative 2, divide this up by negative 2. Whenever we divide by a negative, we have to flip whatever we have. So it's going to be negative 5. So my answer is going to be greater than or equal to negative 5. So just be really careful with those negatives, with absolute values, whether and make sure when you deal with the inequalities, you flip the sign when you incorporate those negative values. Okay. Again, if you have questions on these other ones, let me know. We can kind of go through them or see if you have any problems or issues. Jumping to this one. So the first function, again, we're talking about characteristics of functions. You're correct. Domain is negative infinity to positive infinity. Range is negative infinity to positive infinity. Remember, domain is simply your x values. What are we allowed to input x values, right? And I can see that I can input x like all the way back here, right? All the way back as far, or all the way forward as much as I want. Like I can input, 27, right? Even though I can't see it on my graph right now, I know that 27 is somewhere in my function. Okay, same thing with range. Range is going to be possible y values. So range is looking from like high to low or low to high, right? What are my possible outputs, right? And again, I know this function goes on forever and ever and ever and ever, right? So eventually it's going to keep going up to, higher values. So even though we can't see them on our graph, I know that, 200 would be up there somewhere, right? But again, it would take a while to get there, but range is going to be negative infinity to positive infinity. So remember, this is going to be y values. I'm assuming positive. I would say, I think this is just like a yes or no question, maybe. Again, this is y. It is a positive function. It would have a positive slope, right? If we were going to write an equation for this, it probably goes here. So we know that the y-intercept is going to be like a positive 1. And the slope would be rise over run like that. So we're going to be 1 over 4. So it'd be like y equals 1/4 x plus 1. That would be our function. Negative, I don't know. I mean, there's not really anything negative about the function. Increasing, I would agree. It is an increasing function. Negative infinity to positive infinity, decreasing. I'm not really sure exactly what they're asking for you there. End behavior, the only thing I would throw in with about end behavior is it may be considered an odd function, right? When we start talking about polynomials and like the degrees of polynomials, right? If anything finishes like opposite directions, right? So this one finishes like low to high, right? This one actually finishes on this side low to high. So this is actually an odd function as well. Okay, so anything that finishes low to high or high to low would be considered an odd function. Okay, anything that's even, like this, would be considered an even function because it finishes down, down. Okay, or parabola that goes like this, where it finishes up, up, that would actually be an even function as well. The parabola that finishes down, down would be considered a, hold on, I screwed this up. This one would actually be considered a negative. This one right here would be considered a negative even function. This one would be considered a positive even function. So there's a lot of characteristics of functions that, I want to make sure I get what they're asking you for, but my reaction for end behavior would be an odd function. It is a function. It does pass our vertical line test. Remember, if I took like a vertical line here, okay, and ran it horizontally across our function, it would only ever hit at one point, right? So that does mean it is a function and it is continuous. So there's not like any jumps or anything like that in the function. It's every little piece, right? Like 1.5 would be in my function. 1.55 would be in my function. 1.555555555 would be somewhere in that function, right? There's no jumps or anything like that it is a continuous function. Same thing for 16 over here. So this is, again, negative infinity to positive infinity. Sorry, I can't draw infinity. Range, same thing. We're still going down here forever, and we're still going up here forever, right? So again, negative infinity, positive infinity. Positive, yes, it is positive because it goes low to high. If it had gone the other direction like this, if it had gone something like this, that would actually be a negative function because it finishes high to low. Same thing with slope, right? Like if I have slope and it's sloping down like that, I know that's a negative slope, right? So anything that finishes high to low is going to be negative. So I would say that, I would say this is a yes. This would be a no. Increasing, yes, it does increase. Decreasing, decreasing behavior maybe here to here, right? Okay, so there's this little jog right here in the middle where you can kind of estimate where it's decreasing, like from 2 to 1, it may be decreasing, right? And then in behavior is same thing, right? It's odd. It would be an odd function because it finishes low to high. Okay, so it is again a function. It is again continuous, even though it has this little hiccup, this little jog right here in the middle. Okay, it is still a continuous function. So moving on. Again, I apologize. I already went through this once, but I'm doing it again. Looking at some of these functions. Number 23, I like what you did here with number 23. That looks good. We subtract 9, we get negative 34. And divide by 2, you get negative 17. So that's right on point. With number 24, you got to be careful with this. So you went ahead and multiplied by 3, and it's just an order of operations mistake. But if you have n over 3 minus 10 equals 8, you have to take care of this 10 first, okay? So then you end up with n over 3 equals 18. Then you're right. If you see divide by 3, to get rid of it, you're going to multiply by 3, multiply by 3. 18 times 3 ends up being, 24 and 30, so it's 54. So your answer for this one should have been 54, okay, for number 24. 4 times the difference of a number and 7 is at least negative 52. So if it's at least negative 52, that means it's got to be greater than or equal to. So you got to be careful with this one. Like I would flip that one around. It's got to be greater than or equal to negative 52, okay? This action right here is fine to distribute it. You could also like divide by 4 to start, right? Like if I have n, I'm gonna draw it over here real quick. So if I have n, So 4 times n minus 7 is greater than or equal to negative 52. Okay, you can actually start off by just like dividing by 4. Divided by 4. This is like an equal sign, right? So then I would end up with n minus 7 is greater than or equal to, now 54 divided by, again, we could, negative 52 divided by 4, okay? 48 is 12, right? 52 would be 13. Okay, so you're looking at, 13 negative. Add 7, and is greater than or equal to negative 13 plus 7. You're looking at 6, negative, right? There's my answer. And you had 20. Hold on, let me see. So you did negative 52 plus 28. Gave you, So again, you did this correctly. When you added 28, you add 28 here, but you got to divide by 4. You got to divide by that 4. Okay. Did I get that right? Is that 13 is 12 and 40, right? Yeah. Okay. I think I did that right. Sorry, it's been a long night. Be careful with these. Just make sure when you're dividing by 2/5 right here, which is totally fine, totally correct. Just understand, really, when you divide by 2/5, the same thing as multiplying by its reciprocal, right? So if you're doing that in your calculator, that's fine. But again, just be really careful when dividing by fractions. Again, if you need to see it, this one is correct. I'm pretty sure you did that one correctly. So we added 9, you got negative 8. Multiply by 5 would be negative 40. Divide by 2 is negative 20. So that one's good. That one's correct. Same thing with this one. Ooh, this one. Okay, I remember this one. So when you minus 5, that's correct. What's 7 minus 5? It's actually going to be a positive 2. Okay. So just like little mistakes like that, just be really careful. Then to get rid of a negative 1/3 is the same thing as dividing by negative 1/3, or you can multiply by negative 3, right? So you multiply through by negative 3, it's actually going to give you negative 6 in this case because, yeah, because that 2 is positive, okay? Let's check this one real quick. So you distributed here, right? You got negative 6w, and you got, this negative needs to get distributed to be here. Okay? So when you distribute that, you're distributing the 2 and the negative, which keeps you at that negative 6w and would change that negative 5 to be plus 10. So you got to be careful with that. So this needs to be minus 10, minus 10. So it's going to change to 5. And you're going to, you're going to have to revamp that one. Okay? Check that one out for me. Stuff like this one, I think this was the one I did before. Again, you would distribute this, oh gosh, come on now. Hold on a second. You would distribute this the same way, right? So negative 9 times n is negative 9n. Negative 9 times 4 is negative 36. Equals negative 5, and then this distributes the negative, right? So it'd be minus 4n. That's an n, by the way. Minus 36. You combine like terms if they're on the same side, right? So in this case, we would combine this and this. So we would end up with negative 9n minus 36 equals, these give me negative 9n minus 36. Whenever you have stuff that is identical on each side, we know that's all real solutions or infinitely many solutions. I'm not sure how they have you, respond to that. You put all reals, anything that's a real number is going to work, okay? Just be careful with that. If you ever have something that just doesn't work out to, 7 equals 5, then that would be no solution, right? So, if you ended up canceling out your ends and you end up with something that's that just doesn't make sense, like I said, 7 equals 5, which is obviously not correct, then that's a no solution situation. This one down here, by the way, was good. The circumference one, just divide by 2 pi, divide by 2 pi. That cancels. You're left with r equals c over 2 pi. This one, you're going to use proportions. We can never solve for x as long as it's in the denominator, okay? In this case, the best way to get out of the denominator is just to cross multiply. So we're going to cross multiply here, and set them equal, right? So I'm going to do 2 times x minus 1, and it has to equal the opposite diagonal, which is going to be 4 times x plus 8. Okay, distribute this. On this side, we're going to have 2x minus 2. On this side, we're going to end up with 4x plus 32. You can move them however you like. I always tend to keep my x's positive, so I'm going to go ahead and subtract 2x from this side, subtract 2x from this side. I end up with negative 2 equals 2x plus 32. And then I got to get x by itself, right? So I'm going to minus 32 here, minus 32 here. Negative 34 equals 2x, which means x is going to be negative 17. Okay? So again, when you see those proportions or if you see an x in the denominator, just, the only other thing you could see would be something goofy like, let's say I have I don't know, let's make something up. Let's say I have 7 over 2x equals, 17, okay, something like that, which is goofy, right? Again, you cannot solve for x until you get out of the denominator. So how do I get rid of a divide by 2x? I would just multiply by 2x, multiply by 2x. So that would cancel. I'd end up with 17 equals. Now, 17 times 2x, I can still multiply that. Okay, or you can just leave it. I mean, I would, go ahead and multiply it through. So what's 2 times 17 is going to be 34. So 34x, right? I know this is a bad example. I apologize, but whatever. Divide by 34, divide by 34. There's your answer. Okay, it's an ugly answer, but at least you get the gist. Bottom line, you can't solve for x until you get out of the denominator. In this case, you can get it out by multiplying, or if it's a proportion, you can just cross multiply and set them equal. Okay, continuing on. Again, if you have questions on these, please just circle them on your paper and just let me know. Say, hey, can we check this one? Can we check that one? I'll gladly go through them all. Domain and range. All of these look actually pretty good. Domain is, again, inputs x's. So in this case, domain would be 8, 4, 0, and -4. Perfect. Range would be 2, -1, -1 again, and 2. So it's just these two. It is a function because we know functions exist. We just can't have x values repeat, right? You just can't have, if it's going to pass that vertical line test, for every x value, there's got to be exactly one output of a y value. And so we know if there's multiple x's, if there's multiple, if there's repeating x values for different y values, we know it's a problem. So like in 48, that's a problem. You're absolutely correct, because we have this and this happening. And so that would be a no. But the domain I like is possible inputs. There's only 3 possible inputs. There's 4 possible outputs. That's perfect. Whoops. 49 looks good as well. Again, domain is all the x values, right? Domain is just all the possible x values. Again, this would be an example. All of these would be examples of not continuous, right? They're not going to be continuous functions. Now when we get down here to 50, 50 would be continuous because, it doesn't stop, right? The only thing I would say about 50, it goes forever that direction and forever that direction, right? So the domain is actually anything from, it would actually be like, it looks something like this, -infinity to positive infinity, okay? We would want to include the fact that it can go negative all the way forever and positive all the way forever. Range, you're absolutely correct. This is a 4. Now, the only thing is when it includes that value, make sure you can put like a bracket. A lot of times they like you to put brackets, so it lets you know that it includes that value. And then this actually goes down. So again, if we're talking about range, we're looking at it from a vertical perspective, right? As high as it can go and as low as it can go, right? And you're right, it is infinity down, but infinity down is actually negative infinity. Okay, so you want to include that negative so we know which direction it's going. Okay. It is function. It is continuous. That's good. Number 50. 51, agree with these. So you're looking at domain would be from here to here. So it'd be from 0 to 5, like that. That's good. Range would be from here to here. So range would be at +3, I agree, but it'd also be like a -2. Okay, so this value, this is 3, this is -2. Okay, so be careful with that. Function, no, obviously it doesn't pass our vertical line test, so it is not a function. Down here, 52, again, you're just inputting this value, so this value is going to go in for any x I see. So f of 8 would be -2 times 8 plus 7, right? So obviously I'm going to do the -2 times 8 first. It's going to be -16 plus 7. It's going to be -9. So f of 8 equals -9. Okay. Items like this, again, same thing. -4 is going to get plugged in there and there. So it's going to be 2 parentheses -4 squared plus 3 times -4 minus 19. This is one of those situations where we know we have to do this part first. We have to do that squared, and you have to make sure you square the negative. If you're plugging it in your calculator, make sure you square it. It's like -4 times -4. So it's going to be a +16. So it looks like this. +16. Whoops. It actually ends up being negative So 3 times negative 4 gives me negative 12 minus 19. Okay? And then just multiply and solve it, right? So this is going to be 32 minus 12 minus 19. So we end up with like a 1. 32 minus 12 minus 19. 32 minus 12 is 20. 1. Okay. Find the range. Again, for this one, you're just going to input the values, right? They've given you the domain. They've given you the inputs. So you're just going to take this, this, and this and plug it in there and there. Okay, so the first one would be negative 7. So again, negative 7 squared. Again, plugging in your calculator is super important here, okay? You got to be very careful. This ends up being a positive 49. Negative is going to be a positive 42. So we're looking at a 91. Okay. Next one would be negative 2. So it's going to be negative 2 squared. Again, plug in your calculator. Be very, very careful. That ends up being positive 4 plus 4. Right? Negative times negative. Wait, no, I'm sorry. I forgot. Hold on. It's been too late. Let's do that again. Minus 6 times negative 2. Excuse me. So negative 6 is going to be a plus 12. So how about, let's see here. That's 4. Plus 12 is 16. And then finally, 1 times 2 is, 1 squared is going to be 1 minus 6 is going to be negative 5. So those are my range values. So find the range would be 91, 16, and 5. Again, I apologize. Oh, shoot. I just spilled my drink. Again, hopefully I did those correctly. I'm sorry, it's kind of late. So given the graph, find f of 2. So if my input is 1, 2, then my output's going to be down here, which is going to be a negative 1, 2, 3, 4, negative 4. So f of 2 equals negative 4. Again, this is nothing more than a point, right? Like an x and a y. So if x is if x is positive 2, then y's got to be negative 4. Okay. This is a good graph actually to see too, like, that function's negative, right? So hopefully, the function would be a negative slope. So hopefully, that makes sense as well. So domain and range, again, you did pretty well in the top part. Just be really careful with those negatives, especially when you're doing negative infinity. If you have any questions on the brackets, and then when you're doing functions down here, just make sure you understand what you're plugging in, and be really careful with calculator stuff. If you're using calculator to square some of those values, when we're inputting negatives, we got to be really, really careful. So let's start with that. Again, I went through a couple pages. Hopefully that gets us on to a good start, and we can talk more tomorrow. And like I said, if you have more questions, we'll get them answered. Thanks. See you. Bye.